If you like this video, please subscribe. Thank you. Glucagon and epinephrine, acting through their respective receptors, the glucagon receptor and the beta adrenergic receptor, will ultimately activate adenylate cyclase, increase cyclic AMP, and consequently activate protein kinase A, PKA. When activated, PKA will phosphorylate specific target enzymes that will have remarkable effects on both carbohydrate and lipid metabolism. This podcast will focus on some of the key enzymes that get phosphorylated by PKA and the outcome of that phosphorylation, as well as some other enzymes that get phosphorylated by AMP kinase and the outcome of that phosphorylation. PKA can phosphorylate several enzymes that will change carbohydrate metabolism and consequently affect glycogen metabolism and glycolysis. In glycogen metabolism, PKA can phosphorylate glycogen synthase, and in doing so, it will inhibit the enzyme and glycogen synthesis or glycogenesis will be inhibited. On the other hand, PKA will phosphorylate the glycogen phosphorylase kinase, which in turn will be activated and can phosphorylate glycogen phosphorylase and activate the latter enzyme for the hydrolysis of glycogen. In glycolysis, PKA will phosphorylate specific enzymes and result in the inhibition of glycolysis. PKA will phosphorylate the bifunctional enzyme phosphofructokinase 2 and fructose bisphosphatase 2. The outcome of this phosphorylation is to inhibit PFK2 and stimulate FBP2 simultaneously. Inhibition of PFK2 means there is less fructose 2,6-bisphosphate being produced, which is a necessary allosteric activator of PFK1. Activation of FBP2 will activate this phosphatase, which will break down fructose 2,6-bisphosphate and removes it from the cytosol, thus removing its effect on PFK1. In addition, PKA will phosphorylate pyruvate kinase, the last step in glycolysis, and this results in the inhibition of pyruvate kinase, or the last step in glycolysis. PKA and AMP kinase can also phosphorylate key target enzymes involved in lipid metabolism. PKA will phosphorylate hormone-sensitive lipase enriched in adipose tissue and activate that enzyme, allowing it to proceed with lipolysis of triacylglycerol or TAGs, producing free fatty acids and glycerol. Two other lipid metabolizing enzymes are key targets for AMP kinase. These two enzymes are acetyl-CoA carboxylase, which is the rate-limiting enzyme in fatty acid synthesis, and HMG-CoA reductase, which is the rate-limiting enzyme in cholesterol biosynthesis. Both of these enzymes, when phosphorylated by AMP kinase, will get inhibited. That means fatty acid synthesis and cholesterol biosynthesis will also be inhibited. It is noteworthy that AMP kinase is typically activated under conditions where PKA is also activated by the appropriate hormone such as glucagon or epinephrine working on their respective receptors. If you like this video, please subscribe. Thank you.